Now let's assume that a bag is having 150 good bulbs and 50 defective bulbs. Okay, so 50 bulbs are good and then 50 bulbs are defective. Now we'll conduct an experiment in which we'll draw the first bulb and then see whether it is defective or good, and then we replace it back, and then we take the next one, and we do this at random, and the probability of getting any bulb are all equally likely. Okay, then what is the sample space? Let's first define the sample space. Okay, so what is the problem? We are having 50 good bulbs and 50 defective bulbs, and now we are going to draw two bulbs with replacement, which means we'll take the first bulb, put it back, and then take the second one. Then what is the sample space? Now the sample space will contain four events. What are they? Both the bulbs may be good, or first bulb may be good and second bulb may be bad, or first bulb may be bad, second bulb may be good, or both the bulbs may be bad. So these are the four events which are possible in the sample space. Now what is the probability of each event? See this. Now if you have to get a good bulb, it is going to be 50 by 100, and since you are replacing, the second good bulb will also have the same probability of 50 by 100, which means 1 by 2 into 1 by 2, which is nothing but 1 by 4. Therefore the probability for this good is going to be 1 by 4. Similarly, the probability for this one is also going to be 1 by 4, and the probability of this one is also going to be 1 by 4 and 1 by 4. All are equally likely. Got it? Fine. And now let's define three events. Let's say A is an event in such a way that the first bulb is good, right? Then what do you get in A? The first bulb is good means it is going to be good or good bad, and we know that the probability of this one is 1 by 2 and the probability of this one is 1 by 2. Then what is the probability of A happening? If the probability of A happening is equal to sum of these two, so which is nothing but 1 by, it is 1 by 4, right? 1 by 4 plus 1 by 4, which is 1 by 2. So probability of A equal to 1 by 2. Now let's say we define one more event B in which second bulb is good. Then what are the events you have in that? Good and then bad good. This probability of this one is 1 by 4 and the probability of this one is 1 by 4. Then what about probability of B? Probability of B is going to be 1 by 2, adding these two. Got it? And what about C? Let's define one more event C in which both the bulbs are either good or both the bulbs are either defective. See, in this one I think you got it right. G means good bulb, B means bad bulb. Okay, now what about this? Both are going to be good bulbs or both are going to be defective. Again, this one has the probability 1 by 4, this one has got probability 1 by 4, therefore P of C is equal to 1 by 2. Now the question is, out of about these three events A, B, C, are these three events A, B, C independent or not? So we have to find out whether they are independent or not. So again, how can we find out when three events are given? We have to verify those four formulas. What are the four formulas? P of A intersection B, you should verify whether it is equal to P of A into P of B, right? And similarly P of A intersection C, we should verify whether it is equal to P of A into P of C or not. And then P of B intersection C, we should verify whether it is equal to P of B into P of C. And similarly we have to verify one more formula, P of A intersection B intersection C, it should be equal to P of A into P of B into P of C, right? Now what about P of A intersection B? Now if you look at this P of A intersection B, it is going to contain one event which is good bulb, right? Then what is the probability of that event happening? 1 by 4. Therefore left hand side probability, it is going to be 1 by 4. And what about right hand side? P of A into P of B. P of A equal to 1 by 2 and P of B equal to 1 by 2. Therefore, here it is 1 by 2 and 1 by 2. So what can you say? A and B are independent. A and B are pairwise independent. But then we cannot say A, B, C are independent as of now, because we had to verify all of them. As of now, we can say that A and B are independent. Now what about A and C? P of A intersection C. Now if you see A and C, the intersection is again good and good, right? Good bulb and good bulb. Now what is that? It is going to be, probability is going to be 1 by 4, which means this left hand side turned out to be 1 by 4. Now let's look at the right hand side. In the right hand side, P of A into P of C. P of C is 1 by 2, P of C is 1 by 2. So here I get 1 by 2 and 1 by 2. Now again this is also verified. So what can we say now? A and B are independent from this, as well as A and C are independent. That is what we can say. Now let's see this P of A, B intersection C. Now if you see B and C, if you see B intersection C, the intersection is going to be good and good, which means the probability for this event has to be 1 by 4, right? And what about P of B into P of C? Now if you see P of B, it is going to be 1 by 2, P of C is going to be 1 by 2. So 1 by 2 and 1 by 2. Again, this is also verified. Therefore we can say that B and C are independent. Now if you see them, all the three events are actually pairwise independent, but then you cannot say that they are all independent events, because you have to verify this last formula as well. Now what about P of A intersection B intersection C? If you see A intersection B intersection C, it is going to contain the event good and good, right? So the probability of having two good bulbs is 1 by 4. Now what about this 1 by 2, 1 by 2, 1 by 2? Right hand side is 1 by 8, left hand side is 1 by 4, and both are not equal. Therefore this formula is not satisfied. So what can we say? These three events taken together are not independent, but any two events taken together are dependent. So if the question is whether all the three events are independent or not, no, they are not independent. If the question is if they are pairwise independent, yes, they are pairwise independent. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.